All right, folks. I hope that you have already had a chance to go over this on your own, but this is opportunity for you to kind of see some of the answers. This I will do all the way until we get to through this first page, so 1 through 4. The next video will be about the other problems, which you can probably also see on the website. So to start out with, first thing you need to do is to look at the Lewis structure of sodium. You find that on the periodic table. If you have your periodic table in front of you, first thing you could do is find sodium. Which column is it in? You know that it is in column 1, meaning group 1. That means that that will have 1 valence electron. So oxygen, that is in group 16, and remember anything for groups 13 through 18, you need to subtract 10 to find out how many valence electrons it's going to have. So then you have oxygen has 6 valence electrons. So if this is going to give away 1 electron in order to satisfy its octet, because again it will have 8 on its lower level below it, the way that you would show that is an ion showing that it has a +1. Then you've got oxygen, remember in the octet rule, so this is going to give away 1, so that's going to become positive. This one is going to need to have 2, so that the ion shown in the charge would be oxygen -2. Then this column on your assessment will actually be optional. You do not need to fill in this column, but this is sometimes helpful for whenever you're getting ready to set up this area on this problem. So as we did this in the beginning, this number will always tell us how many of this oxygen we need. And this number right here, this charge, will inform us of the number of ions of the sodium that we need. So I'm going to draw a little arrow that will tell us that we will have 1, and that will tell us we have 2. To demonstrate that, so that means that I need to have 2 sodiums to set it up, and 1 oxygen. And again, it doesn't matter where, it doesn't have to be in the middle as long as you're showing. I'm going to use the correct number of atoms, and I'm going to use arrows to demonstrate that there is a transfer of electrons. So there is a transfer with a sodium. There's a transfer with another sodium. So then there we have that set up. The empirical formula is just the symbols down below indicating how many there are. So that is a subscript down below. Remember, sub meaning like submarine, sub is down below. Superscript are these numbers up here where we have the number above. And then we have 1 oxygen. Using this on the back of your, excuse me, as I look for that very briefly, on your realize that I don't really have that for you all. So unfortunately I don't have that for my tutorial. I thought I had that for us. But if you look at your list of common polyatomic ions, you will see that we've got sodium, or if you also just look on the periodic table, the metal will always keep the same name. Then we've got oxide. This is oxygen here. Oxygen, whenever it becomes an ion, becomes oxide. So here, and then the way that we're going to describe the transfer of electrons is that we would say 2 sodium atoms transfer, meaning that they're going to be giving, I'm going to also write, you can also say give 1 electron each. You can also just write E minus to 1 oxygen atom. The oxygen becomes negative. So because this sodium gave an electron, the oxygen becomes negative, and the sodium becomes positive, and these 2 will bond with an electrostatic force. As a reminder, electrostatic force, That is the type of force that is indicated when you have a positive and a negative. When you have a positive and negative together, they will attract to each other. Just like when you have a magnet, you have a positive side of the magnet with a negative side of the magnet. It will stick together. So that is what we call an electrostatic force. So that's number 1 and that's number 2. Hopefully you're kind of following. This next one I'm going to go a little bit faster. So over here we have aluminum. Again, looking on the periodic table, aluminum is in group 13. So group 13 minus 13 minus 10 will tell us that it has 3. And then sulfur. Here we have sulfur. We'll have 6 is in group 16. So then the 16 minus 10 and we'll have 6. So aluminums will always give away, meaning that they will always become positive. If you think of it, it's like whenever you give something away in your life, that is something positive. Maybe you give a gift. That is something positive you do. Just like a metal, if it gives away electrons, it's going to be positive. And then sulfur is going to accept those electrons. This sulfur right here, only in order to have that reach its octet, it only needs to get 2, so that is going to be a sulfur 2 minus, or at this point sulfide. So again, as a reminder, this number will tell you how many of the sulfide you need. This number will tell you how many of the aluminum you need. So I'm just going to go ahead and draw those 2 aluminum. And I'm going to draw those 3 sulfides, sulfurs at this point, but they don't become sulfide. I could have put it, they don't become sulfide until they start getting electrons. So I'm going to put some over here. So this one now has its octet. This one does not quite have its octet because again it needs to have 2. So I'm going to take one from there. So now we have 2 sulfides, still have 1 sulfur. And then here we have another electron there and an electron there. And then we have aluminum 2, S3. Our name, again, I'm going to do lowercase, it doesn't matter. Aluminum, and aluminum kept it same because it's a metal. And then we've got sulfide, because this was sulfur. Oh, sulfur. And then when it becomes an ion, it is going to be a sulfide. So that's why we're getting that sulfide. So the way that we'd say that is 2 aluminum atoms transfer 3 electrons to 3 different sulfur atoms. The aluminum becomes positive, and the sulfur becomes negative, and the electrostatic force holds them together. All right, so hopefully that is a good gist for you. So that's number 1 through 4. 1 through 4 is for a 2, so that's not quite passing. So if you are wanting to go for a 2.5, you do all the way through 5, all the way through 9. This is getting you some practice on the study guide. Know that the study guide is a little bit harder and a little bit more work than the actual assessment, but you do need to know how to do this. Go ahead and watch the next video if you'd like me to if you'd like to see the answers and me maybe elaborate a little bit more on how to do 5 through 9.